Hello friends. On August 20, 2026, 3 Rust crates that looked completely normal did something terrifying. The moment a developer typed cargo build, malware downloaded and ran on their machine. Not after their app shipped, not at runtime, at compile time, before a single line of their own code ever executed. The crates were arrayref, internment, and append-only vec. 3 popular, trusted names. In this video we answer exactly this question. How did a build script file let attackers run malware at compile time, and how do you stop it from happening to you? Let us start by understanding what a build script file actually is. Alright, so what is a build.rs file? Think of it like a prep cook in a kitchen. Before the chef starts cooking the main meal, the prep cook runs in, chops vegetables, sets things up, and leaves. In Rust, build.rs is that prep cook. It is a small Rust program. Cargo, the Rust build tool, compiles and runs it before touching any of your actual application code. Developers use it for totally legitimate things. Linking in a C library, generating code automatically from a schema, or stamping a version number into the binary. The problem is that the build script runs as a full program on your machine. It can do anything your user account can do. And by default, Cargo puts no restrictions on it at all. That unconstrained power is exactly what the attackers exploited. Here's the part that makes this so dangerous. When you run cargo build, cargo does not start with your code. It works through your dependencies first, in the order they depend on each other. And for each dependency, it runs that package's build.rs script before anything else. So by the time cargo even glances at your own source files, every build script in your dependency tree has already finished running. Those scripts run with your full user permissions. They can read your files, write to disk, and make network requests. There is no sandbox, no firewall, no prompt asking you to confirm. It is like hiring a contractor to renovate your house and handing them your master key before you have even met them. Next, let us see the clever trick the attacker used to make sure developers actually pulled the poisoned version. So how did the attacker make sure developers actually pulled the poisoned version? They used a clever 2-move trick. First, they published arrayref 0.3.10, which secretly pulled in the malicious proc macro 1 package as a dependency. That happened on August 20, 2026. At the same time, in the same scripted burst, they yanked versions 0.3.5 through 0.3.9 of arrayref. Yanking a version on crates.io means it is skipped by fresh dependency resolution. So if you ran a fresh dependency resolve that morning, Cargo saw all those previous versions as off-limits and pointed you straight at 0.3.10. Existing lock files that already pinned a safe version were unaffected, but any fresh resolve had only one choice. Cargo even shows a warning nudging you toward a non-yanked release. The attacker turned that helpful warning into a funnel. Up next, let us look at how proc macro 1 disguised itself so well that even a careful code review missed it. Here's where it gets really sneaky. The malicious package was not called arrayref or anything suspicious. It was called proc macro 1, just one character different from proc macro 2, one of the most downloaded packages in the entire Rust ecosystem. The attacker copied the real proc macro 2 library code almost exactly. So if you downloaded proc macro 1 and read through its source files, everything looked legitimate. The builds finished without errors. Nothing felt wrong. The malicious code was hidden entirely inside build.rs, the prep cook script we talked about earlier. That script reassembled a remote server address from scrambled text fragments, turned off security certificate checks, downloaded a second program, and ran it on your machine immediately. The library itself was clean. Only the build script was rotten. So the natural question is whether any security tool could have caught this before it ran. So could any tool have stopped this attack? The good news is, tools do exist. Cargo-audit checks your locked dependency list against a public database of known security problems and flags anything dangerous. Cargo-deny lets you set rules for your project, blocking packages by name, license, or source. Cargo-vet goes further, requiring that a real person has reviewed and approved each new package before it enters your build at all. But here is the hard truth. None of these tools would have caught this attack. All 3 rely on someone already knowing a package is bad. A brand new malicious crate with no advisory yet is invisible to all of them. Understanding that gap is the first step. Next, let us look at the concrete steps you can take right now to harden your pipeline. So here is your concrete checklist, drawn directly from this attack. First, pin your dependencies and commit cargo. Lock to version control. That file records the exact version of every package your project uses, so a fresh install never silently pulls in something new. Second, turn on two-factor authentication for every crates.io account that can publish packages. The exact entry method in this attack was not publicly confirmed, but a compromised account or token was the likely path in, and two-factor authentication raises the cost of that kind of takeover significantly. Third, run cargo deny in your continuous integration pipeline so every pull request gets checked automatically. And fourth, this one is critical. If any machine ran cargo build during the exposure window on August 20, 2026, treat it as fully compromised. Do not just scan it, rotate every credential, every secret, every token it ever touched. The key lesson here is simple. Trust is earned at every layer, from the account, to the crate, to the build script itself. Stay safe out there, friends.